So hello everyone. Thanks for tuning in today's session. My name is Nina Hayani and I'm the training manager for iTrain Kids. Before we start, I would like to appreciate your effort for making time in joining us today. I hope all of you will gain something benefit from our session today. Now, before we even start deeper in our topic today, let's have a little exposure about us, iTrain Kids, and let's get to know what we are doing for our community in these past years. So that's gonna be the content for our today, and then just let's go through briefly about iTrain Kids. So we actually teach little explorers the essential skills like 21st century skills. We believe that young people really love to learn. So at iTrain Kids, we actually give them the chance to learn by building their own video games, and students can learn the core coding and logic skills while also they are being creative and enjoying themselves. So basically our unique courses actually tailored to maximize both learning and fun for every age group, as early as 5 years old until 17 years old. Well, we aim to put as the iTrain Kids actually a playground for them to know what is actually coding, and here they're able to develop their own digital masterpiece. Some of them are literally interested in developing their apps. Some of them literally interest in video game because like their parents, my kids all the time with their phone, so why not I send them to iTrain Kids instead of playing just game, but they also learn to develop their own masterpiece or their own video game. And we also encourage them to be a creative problem solver, and they will learn through here. Like our motive is they will learn as they play. So yeah, that is some of the background for iTrain Kids. And let's take a look of me myself. So before we start further, maybe I'm just gonna share a bit like my interest about myself. So basically, I have a 3 years experience in education and training for kids. But my passion is always to learn new things that will benefit myself and also our society. And that's why I think I lean more towards coding. That I found that coding, it's also one of the way to teach the new, the new talents. So I'm actually coming from a psychology background, but I train myself to be well versed in coding and programming so that I can efficiently teach the vital digital skills to kids with the help of my background, hopefully. So I also learn to guide the kids by giving them the right motivation, because coming from a psychology background, I think the most part that I could have is that helping the motivation of the kids, maybe to solve problem and also help them to increase their critical thinking. Also, I think with my background psychology, I think I learned a lot about how to entertain, and also from my psychology background, I learn how to select the intervention. So whenever I deal with the behavior problem in the class, I also learn to inspire our future generation, hopefully, to really chase their dream and goals, no matter what they want to be in the future. So currently, I'm still in with iTrain Kids and still in the aim of educate this new breed like our digital native who really know how to capitalize the technology and aiming to transform the world. Because some of the kids that I actually found that okay, why you are in this coding class? Literally, some of them like, oh, I want to be a hacker or something, I want to hack into account. But literally, you're gonna stop them there, like to, try to tune a bit their aiming. Instead of being hacker, why not you're gonna be like Steve Jobs, all right? So you create like, you become your own product like Apple or somewhere, okay? So this is a part of me, and then I would like to share with you all, right? Okay, and without further ado, then let's continue to this our topic today. So some of us are still like asking what is actually the coding or programming. Is it the same like coding versus programming, or is it the same with the computational thinking? Like, what are those? Some of us like still able really to tell this. So the terms of this coding and programming is, I think, is often used interchangeably, and some parents may wonder if there is any difference between these two. So before like we go to that question, maybe I would like to throw some computational thinking into the phrase. So let's spend the rest of our session to try to figure out this term together. Okay, so coding versus programming is actually quite a lot. They quite a lot like being arguments. So they're saying, oh, those two are different. Those two are different terms, and some of them is saying, oh, they're actually the same. It's just like it's depend on the where it used. So basically, there is a camp out there which actually advocates that coding is actually like a low level. We use it in the low level work. Basically, you can say it's teaching, what they call, it's actually usually run in the application, translating the logic into code. That's actually a kind of another word for programming language lah, but literally we use the logic into code so that we can run our application. Programming in the other side is actually a form for the higher order work, right? So mostly it's designing logic to solve problem. So basically they would say that coders is usually for the low level, and then the programming is a bit expensive, which is you will use it on the higher level of solving problem. So I think it depends on the branding. So I personally don't see much difference between coding and programming because it's really two things almost the same. So what I'm more interested in is more as a STEM educator, I'm more concerned into the computational thinking. So actually, why is this computational thinking? Let me change that for you first. Okay. So as we can see that actually computational thinking, it's involve solving problem, designing system, and understanding human behavior. Okay, well, you can see by drawing on the concept fundamental on computer science. But actually, this belief is actually, we start with the aim of when you understanding human behavior and also understanding the user needs, all right? So that is why we're actually in a huge belief that human-centered approach of design thinking, when actually the the computational thinking is always related when you want to jump in the computer science field. So this computational thinking will comes in the step after you know what is the problem, and then you know that actually what's the problem you want to solve for. So by thinking that reformulating, okay, and seemingly difficult in once everyone know how to solve, perhaps maybe by reduction, maybe you want to do a simulation, all right? So in iTrain case, we actually want them to have this computational thinking by giving them the case. For example, we ask students to break a problem into a small parts, in a small problems. For example, when we have one of our courses, which is Scratch, okay, we will start with one sprite and then make the other sprite to move, and then move on to the next sprite when you are trying to do next task. For example, you want to do conversation, or the next step you want to make after they're doing a conversation and you want to make them jump. So for example with that, Scratch also comes with this term called as experimenting and iterating. So they're literally giving you a situation, a case, and then they ask you to solve problem. Okay, break down the step by step. All right. So I think that also computational thinking is not about writing all the codes together, and basically it's the step to understand it. We always talk about like how we want to solve the problem efficiently, like effectively. So I think it's about the skill that nowadays everyone must have. It's not about like because everyone can come out with a different kind of solution. Maybe I'm going to come out with this A solution. Maybe teachers out there will also come out with the different solution. So the kind of step to do the problem solving is different, but actually it's actually the matter of how you will solve that problem when you already break down all of the problems together. All right, so far so good. Yeah, just to make sure that I'm not talking to myself. All right, if you have any question, then we can put that to the last part, okay? All right. Let's just go to the next slide, which is why I always saying that coding is the new ABC and all. Okay, so, right. Oh. All right, so why we are talking about like always coding is the new ABC? I think by that one is always we learn about trial and error, and also to develop the algorithmic skills and to train our kids to be a divergent thinker. All right, what all of this is talking about. Okay, so for example, the trial and error, right? So it involves tasks such as implementing the trial and error method. So this method is actually, we know that the trial and error is actually a process that you have to reach a successful one. You have to try a different number or solution until you can gain the successful one, the right, the right case. So we trying to recall actually you remember all of you guys remember the block game where actually the kids will try one piece after another until they will find the one that fits. Actually, that is like you have the rectangle and then you have the circle, You want to fit in the circle box. So that is example of trial and error learning. But nowadays coding made it tech savvy. We love that actually we have a different kind of program that actually you can turn into different apps or tasks that ask you to perform this kind of trial and error task. Okay, for the second one is algorithmic thinking or skills. Okay, so when we're talking about algorithms or algorithmic thinking, this is very specific. It's actually a procedure, a step-by-step procedure to solving certain types of problem. So this kind of algorithm will always result in a correct solution. Let's take an example for mathematical formulas, for example. So also when we learn that, for example, technician repair electrical components, we can see from that also they are also applying this algorithm. So the analysis of requires mathematical knowledge and also to create the schematics, right? So in coding, a line of code that made up from the program need to be in right place. Otherwise, you will face errors. So all these errors are like a trigger to your kids' curiosity. For example, they didn't turn out. So maybe your kids will ask, why this thing will not happen? Okay, so they will gain for another kind of a solution. So this is turn their challenge in debugging skills, as they will figure out what is actually wrong. So that thought process will actually sharpen their algorithmic skills. And also, last but not least, all right, we'll try to actually exercising a new way of, thinking. Actually, some of us really don't think about being a divergent thinker, like also me. Some of time I also prefer to be just straight to the point person. So actually, when we have this divergent thinking, it always train a person to take an idea and see many outcomes. For example, okay, let's say if someone were to ask the question, what is the use of a pencil? So convergent answer will answer like, okay, oh, pencil is to write. But as a divergent thinker, it will come out with various answer, maybe such as, oh, pencil is to writing, or maybe poking holes, maybe as a weapon. So this coding skills is actually really shapes your kids to have divergent thinking. This will always assist their creativity in problem solving, as well as I think the formation of ideas. They will always like part of their brain, like digging for another a creative problem solver. So creativity also think about like it's always be the fools to a solution for a kind of real world problem. I always relate the real world problems to their lesson. So for example, when we are developing the game, and then they encounter this problem, why this trigger won't happen? Okay, is that because something will lead to something. So for example, imagine we want to create a video game. So how do I implement this real world problem to them? So for example, before you creating a video game, actually you will create the layout first. You will create the design, you will create the layout, and then you will put all the characters. Okay, so in order to match with their understanding, I will put an explanation. For example, imagine you baking a cake. First, you always put the cake first. Okay, for example, you bake the cake first, sponge, and after that you will put a cream on top of that, and then after that you will put cherry on top of it. So it's actually a step-by-step procedure that the kids actually can understand from that. All right. So from that, that is why actually uh, there is a question like, oh, why we need to learn to code. It is actually important to have a computational thinking. What do you guys think? Is it a must that we learn to code, or anyone who don't learn or who doesn't learn to code will be left at the back? Anyone? Well, actually, this is why we want to actually slay, the popular fallacies of those who actually learn to code. They're actually really hard, really afraid to learn coding because, oh, maybe coding is complicated. So a lot of like people will say, oh, coding is hard, it's all number. Or those who learn coding is very, what, uh, very, I don't know, maybe they will say this, oh, learning coding, I think I don't want to be learn coding because later I don't have friends to talk to. So they will give up along the way, right? So there's actually no such thing as instant coder. You learn and then you will get, oh, you get to be a hacker. You will be a instant coder. No. So of course, in becoming a good coder, it takes a consistent effort, and also practice just coding. Maybe you're gonna sleep with a book course. Maybe you're gonna sleep with the dummy how to code dummy book how to code, right? Okay, so maybe you even like when you're working on a project, you will sleep about it, right? So it's just the same. Imagine that you want to learn a piano, for example. You need to practice more and learn new songs to be familiar with the notes. And also, in order for you to play it well, you don't have to be afraid to fail because that is the only way that you can make a progress. So I hope everyone is not get affected by the illusion of how hard is coding, and because that will stop you to become a maybe who knows you are a competent coder, right? Okay, and when we're talking about like someone who learn code actually will end up being lonely or maybe socially awkward, well, that's not true because we all familiar with the old saying that goes like, kids shouldn't stay in front of the screen for too long because it's not healthy. So this is actually a common misconception that the coders always sit behind a desk and do nothing but stare at the screen for 8 hours. They will not eat, they will not take a bath, or they will not going out from their room. So this actually they're trying to make it worse by a lot of people think that actually coders or being a coders or joining a coding club will actually tend to be a socially awkward. Well, actually that is not true because by developing a successful apps or game or video game, it's actually requires a team effort. Like you being assigned in a assignment group, you actually have a team. Let's take a look for PUBG game example. Um, it took a large group of coders that working together to come up with the final product. It's not like only one person doing it. So maybe there's someone will do on the design. Maybe some of them will do about like when the enemy hits the police, for example, there is some of the program. We talking about the back end of the game, lah, right? So you likely meet a lot of team, maybe the juniors, maybe the seniors. So some of them is actually have been in the field many years, and then some of them like already been training, and also probably they're gonna give you some of the knowledge or training that you'll need. Maybe you are interested in video game, so why not you joining this group, you can benefit some more. Okay, so also like this is actually we have made a move. Actually, we working with Google coding for girls. Okay, so actually coding also is no age, no gender. Okay, it's not only for boys. Some of someone says that coding is not only meant for boys. Okay, so well today you can see also like most of my student also is like from is a girl. So you also can see nowadays there is a lot of coding that making girls feels like they don't match or they not fit in. But this coding is not a biological things that should be a gender bias, right? So I think it's time to break the spell, which is for over the past few years, a large of number jobs actually were taken also by girls. So we would like that trend is actually likely to continue. So we can have the girls to have an early exposure about the industry, and also there's a lot of actually case or in the news that actually the girl has already started their own movement. They want to help the community to make better in the community. So instead, they are being the head of the program or the movement. So we don't want literally all of the kids or maybe a person have these wrong fallacies. We don't want them to be too early to afraid about coding is hard and all. So, yep. Uh, Let's we are talking about the trial and error, and also this is some of the example actually when we see about problem solving. Okay, everyone can see that it's actually a step-by-step procedure, which is actually when we encounter problem, lamp doesn't work. Right, so are you gonna check where the lamp is plugged in? All right, and then we're gonna check yes or no. So yes, we plug in the lamp. So it's not about the plug-in. Then next we check about the bulb. Is the bulb burned out? So if yes, we have to replace the bulb. If no, we have to buy a new lamp. So it actually helps you to break down small parts or a small problem into step by step. All right. So the trial and error that we're talking about just now is actually, I just want to share out with you guys this thing. So the mom tried to fit in the parts. So we actually know that, oh, okay, the kids actually really have we can tell that they actually can fit, the kids actually have a earlier exposure about the computational thinking. All right, so why we have to learn to code? This is just maybe some jokes to tell. Maybe you can talk to your future overlords, because we assume that in the future all of the coders, or maybe all of the coders will get the job. Maybe we can assume, since the Industrial Revolution 4.0 is moving forward, then all of around us, the environment itself, will be handled by machine or AI. Yep, so this is not from me, but from Steve Jobs. So everyone should know how to program a computer because it teaches you how to think. Do you guys agree with this? Yep, okay, so even the president thinks so, right? It's not only president, but also president mentioned that don't just play on your phone, but program it. It's gonna be huge for now. Okay, so I don't think I'm not forcing everyone to be a coders or to teach your student to become a coders, because probably all of us don't want to own 10 million or 56.4 billion like Mark Zuckerberg, because we don't want really become these dudes, right? Maybe we don't have that in mind, so yeah. Okay, so we realize that codes are all around us. We actually realize that most of us encounter with the a situation where actually you go to bank and then there is no longer a person that assists you. There is actually, you will be welcomed by machine. You will be assisted by machine. And that is why we think that, oh, literally that is normal. In the future, we will think that, oh, after this, maybe all the job will be replaced by machine and all this AI. So we think that to impose this code, all right, is actually same with our principle. When you learn to read, you can then read to learn. But actually, if you learn to code, you also can code to learn. Okay, so that's why is coding, there's to be direct a question, is coding is difficult, or what does the coding looks like? Some of them will think like, oh, maybe to be a code, maybe when I learn this coding or programming, I'm gonna learn about all the scripted text because it's so hard. Probably I will not go to it, I will not go to Bath. Okay, so right, for that, actually we want to also inform the parents, or maybe coding is not just for computer scientists. Okay, let's take a look of what is actually coding, right? I'm having a problem. Okay, I missed that. All right, so does it look familiar to you guys? Yeah, well, that's a part of coding is. How about this? Well, actually, you can see a set of code. Functions say hello, name, hello plus name, and then that is the output. It will say hello, my name is Adam, and you also can do a greetings Adam. Well, that is actually is kind of the output, of coding, a script of coding, right? Or maybe you guys have encountered with this situation. Okay, which is actually, this is a really simple type of coding, which is, we call it block programming. Okay, as you can see on the screen, there is a few, few of class that you have to combine them. When button one click, it will do what? It will do or call sound play. Okay, so it's actually very straightforward. Right, so it's actually like this kid has come out with the Hello Poor apps. Just they're talking to the cat, and then the cat can do what? So actually they created their own simple apps by doing that. Okay, now let's try to do a little bit exercise here. I have the Flappy Bird from A to B. So our objective, okay, is we want to make the Flappy Bird move from A and B, which is, that is the quickest way. But the problem is, you can only move in the direction you face. Okay, so now we are trying to break down the problem. If we cannot move in the direction of our face, then we have to use either move or turn. So anyone would like to try to solve this? Let's try to take the first step, being a coder. You can unmute your microphone and then mention the solution.
Can we turn the face to 45 degrees upward?
Well, seems like you're using the 45 degrees. Probably we can try to use a simple one first. Maybe you're gonna use the move or turn. So maybe move, turn, move. What do you think? Without we using the degree first. So we can either use move or turn. Okay, so from A to B, which one is the quickest way? Can we just go straight to B something? So there's a few points there. Katie, you want to try again? There is no right or wrong, because as mentioned just now, we all come up with our different kind of solution.
Okay, hi.
Hi.
Yeah,
Hi.
because the thing is like, if we move diagonally, the things is the quickest way. But in this situation, you say that we cannot it means that we cannot program it into 45 degrees, for example. So the quickest for me, I just say move forward lah. One step, two step, move one, move two, and then turn up, and then move, then we reach the point B.
Okay, good job. Thanks for trying.
Okay.
Other than that, that's from Miss Wei. Yeah, all right.
Yeah.
Good job. And then the other one, other than else? Okay, I'm gonna give another one. Maybe one chance of you guys want to try. So if I'm gonna use to move, gonna move here, and then turn here, here, here. Probably that's one of the solution, right? Can be. Right, so don't worry about that. Good try, thanks everyone. Thanks for trying. Okay, so yeah, actually, like I mentioned, there is a different kind of solution. So you can move, and turn, and also try to move again and move. So that's only the direction on your face, right? When you move, and then you turn, that is the direction of your face already. So you just straight move, okay? And also when you program it, okay, so that is actually you breaking down the step. Okay, I know that you have to move, turn, and move. But when you want to put it on a very specific question, a very specific direction, you will mention turn left. Or maybe just now you say turn 45 degree, right? It's a more specific, then you will program it into the, for example, the system. When you want to program it in the system, this is how actually you will come up with. Well, different kind of language is actually, they have different kind of instruction, or what they call as the command, okay? Like I can point out one of this example in a print function. For example, you want to mention it, hello world, my name is Nina Hayani. So when I want to program it and put it in the system, when I'm using the Python language or Python, Python, what they call the Python program or software, it's kind of different. It's just simple. That's why nowadays people are going for Python, because it's more simple in instruction. I just have to call out print and then type the text, hello world, my name is Nina, and then put the double quotation marks and then just print F5 to run. Okay, but in another software or program like Java, it requires you to put a lot like more of complicated, or maybe what they call complicated instruction. That's why I still remember about my my previous colleague, or I can say like she's the one or teaching me or involved in coding. She mentioned that when you want to learn to code, you actually have to have eagle eye, because some of the script you mistakenly put it, for example, there is colon right there, but you didn't put the colon right there, so it will turns out as error. That's why, yeah, eagle eye. So it's very, you have to very focus, very, very detailed in writing the codes, right? So that's why when you ask them like very specifically, we learned that coding will teach us to think sequentially, right? So obviously where you have to achieve a goal and then learn how to get there in a very particular order or particular way, right? Like I mentioned also, coding literally has no age, no gender, or no color, because you will only learn about typing the script in black and white unless you learn about block programming, because block programming is like mostly you can see that's for earlier age. So you can see like kids, you know, if you give this type of scripted, you know, scripted code, you will give to kids, they will absolutely become afraid and you know, be, teaching or maybe learning the coding itself. That's why there is actually a whole set of software, a different set of software when you want to approach this kind of age. So like ours, one is the youngest, 5, and how we approach them is using the Scratch programming, introduce them by the block programming that has a colorful section and then animation. So when you give it this type of coding to them, you help them to build their computational thinking and also gain their interest to love coding. Like, oh yeah, coding is actually not that bad. It's fun. So I can come up with my own video. I can come up with my own games or animation. Yep. So, yep. Learning to code takes time, patience, and creativity. So that's why I mentioned just now. It's a 3-way. Build, test, and learn. And then you're gonna, if you fail, if you find errors, and then you're gonna build again, test, and learn again. So it's always simultaneously. So that's why we're actually trying to prepare our students or our future, okay, to learn about the valuable skills, right? So this is just I got it from future jobs of reports. They actually shared this to me, and we can see that it's the top 10 emerging jobs in 2020, right? Most of them are related to the what you need is actually coding as the, you know, as the surface. When nowadays also they are always talking about like data analysts or data scientists. We learn about AI, you know, artificial intelligence, machine learning, you know, big data specialists, right? All the IT requirement lah. So this is also to share like our coding skills in demand nowadays, right? Some of them like post on the job post, programming is a definite advantage. Another one, this is from SIMDB. Okay, they also like welcome those who have a programming, data analytics, and creative. So being a creative person is actually pays you a lot of money. So yeah, it's also to share with you guys. Proficient user of Microsoft Office, Excel, micro including macro. So all of this actually is high demand job nowadays, or high demand skills nowadays, right? So we can say actually the future is digital, right? We can see nowadays actually the creative art is taking place. Most of the animation is growing, right? And also, I think for the creative art itself, it's more obvious in arts and entertainment itself, right? Aside from the purely commercial and work-related function, I think digital also open endless opportunities for this, all of the creative expressions. I think from video game design and movie, the virtual, you know, virtual function. So all of them is asking them to create music and artworks of the future. Okay, and you can see as the point, intuitive TV shows, music, and games that are already tailored to our individual tastes. Okay, so that actually is a high quality entertainment. So it's always on the market. Can see that VR, actually the virtual reality and augmented reality, will also open to this all new audience that we have. Actually every day we will have a new audience, creating a new opportunities for all the social interaction. Basically, if you have no matter how different you are in the background, age, or maybe we can see nowadays even a simple one like Didi and Friends, if you're familiar with that, is already moving step forward. If even if you create a simple animation, a simple song like that, it's already become trend. Okay, it's played in the YouTube, like a million views. All right, all of them is actually because it's not only enjoyed by the kids, but actually parents also enjoying this song, even though it's just it's just from the for the kids background like Didi and Friends and all, right? So this is actually also a challenge for the future. A lot of like some of from the research, like some of the percentage is current job will disappear over the next 20 years. Like we can see machine is replacing our workers in the factories, bank, or any industry. Even you can see in the education side also, accountants, hospital. So by automating many lower skill routine tasks, okay, of the higher skill like doctors, all of this will able to do the work that currently doctors without AI. So this will mean a hollowing out of many high skills profession. It will, like I mentioned, like remaining jobs will be those jobs that require only empathy and human contact. For example, maybe like a nursing for elderly or infants. So, yeah, this will be replaced by the future of works. So we also they're also like trying to come up with this saying and this belief that our children future jobs maybe don't exist yet. So the skills that they are learning now, okay, is already covered up. So we really don't have any idea the jobs in the future. That's what are our kids will actually come up with, right? So for now, like working in a repetition kind of job, 9 to 6 p.m., all this thing, right? So this definitely not gonna be our future. So when AI is already replaced human repetitive tasks, the future job will definitely require more creative problem solvers. Okay, and also it can be said that a human will definitely working or maybe working together side by side with the robots. So the gig economy will also see many workers of like freelancers or working project from different size of company and also multiple markets, maybe time zone. So that's why we want to have the step to actually preparing our children on this kind of future. So we can tell that actually the valuable skills of the futures nowadays is creativity and the way how you're gonna adapt. Example is the entertainment. So all of this creative and adaptability, right, is actually try to teach the kids to use our uniquely human empathy and probably try to understand and create things which will be used and appreciated by maybe other humans. So next one is logic and problem solving. Okay, so example, that one is more like the ability to understand and changing a set of circumstances, and continuously we want to find always a new creative way to solve issues, right? Psychology, one of the way. Okay, so also this technology fluency, like we want them to understand of how computers think and operate. Okay, maybe like how to manage the machine or the computer, or maybe to extract the maximum amount of productivity from them, right? So probably there can be example of designing new materials or maybe medicine with the help of this artificial intelligence. So this one is actually what we did at iTrain Kids. This is some of our program example that you can see down there. We believe that they actually really love. You know, when actually I myself encountered this situation where the kids were very excited to come to class because they cannot wait to do the next progress. Okay, this week we're gonna build the house, and then next week we're gonna ask them to do a conversation inside the house, and then we're gonna learn about another different role. So all of this we're doing by a simple of coding instruction, like we adding event, we created event, we created the actor, we updated the design. So all of them requires them to think about what to do next. So plus with the, this kind of animation, who doesn't love about, teaching this or maybe learning these codes? They love to play the video game, so they love to come up with their own, because they can design their own. Oh, I want to design my own castle, ice castle, fire castle. So they can come up with their own different kind of story. So I would like also to share actually, iTrain Kids actually try to impose the coding skills for the kids to actually like learn about storytelling. For example, it's like a storytelling way. We want them to see this coding is not that complicated. By doing that, we actually try to impose like, yes, more of hands-on training. Okay, so for kids, don't just talk concept to them, and then we need to show them. Okay, so I think this programming is a hands-on experiential learning that always requires training. It's more than just reading a book. So even after you learn about the concept, it can be intimidating when you are sitting in front of computer and starting a new program. So it's in iTrain Kids, actually we give them one-to-one experience. Okay, it's like more to one-to-one experience, so that they can understand, and it will give them the chance, to think their own skills. So our class is really a bit like a small classes lah. Like our biggest ratio is also like 1:5. So all of this is actually, all of the students actually can engage with the instructor, and also engage with their friends. So usually how we run our class, when the other kids is already finished with the task, we'll not ask them just to sit there and wait after the rest of them finish. We usually ask them and encourage them to go help the other student. So like, okay, why not you just finish your task? Why not you help the other student to solve this problem? Okay, so with that, they also will learn how, to work with team, and then they will engage each other, right? So for this one, when we saying about building lifelong skills, right? We want to tap the latent potential with coding. Um, there is actually more to coding than just one hard skill, right? Is like coding also helps all the student to develop a multiple of additional skills other than problem solving. Maybe we're gonna help them to learn about logic, language, and even the creativity itself. So yeah, we teach kids to create their own digital masterpiece using software that will help them learn as well as express their creativity. Like I mentioned, even if they are at the same age, we will give them a different kind of software or output so they can actually choose what they want or what software they are more interested to. So and this is just a study shows that students who learn coding perform 16 higher better in other studies such as mathematics, English, and science. This is what actually we try to share with the parents, because some of the parents also give a feedback that actually, okay, my kids already like started to try to figure out a problem. Then they like to do maths. They always realize, oh, maths is hard and all. So I think by seeing this real achievement, they will also boost the students, the confidence for the student. We have a real case where actually the student is actually quite shy, but after they're actually moving with our progress, he quite talkative, and he already being open up to some of their friends. Okay, so this actually really open is actually like an eye opener for me too. So we see that is coding is new at BC. We're talking about this quite a lot. So there is always a perspective, which is from the psychology itself. It will bring benefit to the future. And also we really hope in the future, in every city, there will be a hub that help these kids, to learn all these skills, and probably the what most important is about their early exposure, so it can help them in the future. So we know that actually some of them think that the future is digital, right? If you, from the creative art itself, okay, every field is already taken by digital industry, right? We also believe that when we engaging children through their own creativity, we don't want them to lose the potential of learning to code. Okay? We don't just teach them to code, but we want also ask them to, to love to learn, because this coding becomes the tool that we want to run with their own imagination. So no matter whatever they learn or whatever they have come through with, they're always gonna keep the interest around that, even if they create a simple video or video game or maybe apps, right? Okay, so how do we want to get to know like how we how to join us and all? Where do we should I start? Well, actually, it's quite easy. This is actually the link or maybe the site that you can visit for more info. Code organization, Code Academy to start with. But literally, if we have no, we have no idea, or we have no background in coding, you always can start lower with Scratch first. Okay, but Scratch is more like you're doing all the animation. Okay, but the MIT Apps Inventor is more you towards apps. If you lean more toward apps, then they will teach you how to develop by a simple code, you know. It's almost same with Scratch, but Scratch is more like a storytelling, but MIT apps is more to like more serious apps, maybe painter apps or photo book apps, maybe just come up with a simple calculator apps, right? So there's also for iPad user, Swift Playground. This one can be as the early as 5 years old, 5 to 6 years old, right? So yeah, that is a useful resources and support materials. You want to get to know more about computational thinking, and there is also a Scratch guide for educators. All right. Okay. So before we go to the exercise part, okay, we will get to 5-minute rest first, and then we'll continue with the sharing session, or maybe you want to have a Q&A session, and then we're gonna go straight to the exercise part. Okay. Okay. Hi everyone. Welcome back to our session. Yep. Hope you guys have a good rest of these coding things. Yeah. All right. So to continue with our next session is just about like the the exposure to our some of our programs. Okay. Well, you yourself can experience about using this software, and maybe we can think of a way like how to put in this in your classroom, for example. So without further ado, then let's go start with the first program first, the youngsters that usually we do this for the age 5 to 9 years old. So just a simple instruction. So for the next session, if you guys interested for the next session that will be held on Saturday, that's gonna be the most comprehensive, like more step-by-step procedure. The tutorial will be and the training for Scratch. But before that, we will give you the learning materials for you to go first. Like after the session, we will give you a link so that you can visit for go through the learning material first, and then on Saturday, then you will have to sit for the training for Scratch. But for today, I'm gonna share with you about our program, like more to Scratch, and also with the construct tree. So it can give you guys, an idea about how you run the program itself. Okay, so in the chat section, I will give you guys the link to this Scratch MIT. Maybe some of you guys familiar with this. So, oops. Okay, me to everyone. Okay, in the meeting. So I'm gonna attach the link there on the text section. Maybe you guys also have a different screen. You guys can test it on together. For now, I'm gonna share my screen for that. Okay. So have you guys any of you guys familiar with the Scratch? MIT Scratch before?
Heard about it, but never tried it out.
Okay, maybe you guys can try it today. Okay, so once you click on the link, you guys will visit to this Scratch website. Okay, so we're just gonna do a simple, very simple task. Maybe you're just gonna try to do the conversation today, or maybe the movement. Okay, so as you can see, that is where we call actually a sprite. Well, the one that you can see from my side is actually the cat with the background, with the grass background and all, right? Okay, so before we always start the class, we will give them a simple task, step by step. Maybe they're in the first class, so we'll give them like, okay, try to make the cat or your item. So there is a way of, introducing the background, introducing the sprite, all of it actually take part in the lesson. Okay, let me see, there's a chat. Okay, good. Okay, so actually you can change the sprite. So from here, okay, let me get the red pen first. Okay, so this is your sprite that actually, okay, from here. So once you delete that, you can change to another sprite. So for example, if you want to choose another sprite, then you can choose it from here. Okay. So they actually come up with their own sprite for the Scratch website, but also you can draw or you can come up with your own sprite. Normally, when I want to impose the kids' creativity, I will use the pixel art to ask them to come up with their own costume or their own sprite. So imagine, or let's say I come up with Pico, maybe penguin or maybe Pico. So let's say I come up with Pico, so I can just delete the cat itself. There you go. So how do we want to make sure that Pico can introduce herself? Then that's the part where actually there's a few function of block. So as you guys can see, that is actually the design. So every software, we actually have the what we call is the front end and also the back end. So the front end is all the way that you can see the design, the sprites, and backdrop. But the back end, it will be different. Okay, so for example, the back end, either the back end is block programming, or is event programming, or is a scripted event, or is a scripted code, for example. So if they're involving the block codes or block programming, this is all the function. As you can see on your left side, okay, there is actually in a different color. So kids really like this. They can differ the function in by color. So you can see there's event, control, sensing, operation. If you, for example, the Scratch also can come up with a storytelling kind of thing, but it definitely gonna involve a whole set of block programming. All right, okay, this Scratch, it can be advanced, it can be that simple. So, well, we're just gonna start with a simple one today. So our objective is to make Pico talk to us. So what do you guys think? Which one is involving the conversation? Are we going to use the motion, looks, sound, or event? What do you think? The very first step that we have to do. Does anyone want to try? Before we ask them, we ask the sprite to talk, for example.
I think it will be the sound.
Sound? Why do you think it's sound?
Because I want the sprite to talk.
To talk, to produce your own voice. Okay, we can do for that. Yes, we can do that by adding a sound. So for example, the trigger, there's always a trigger for that. Yes, you can involve your sound, or you can make the conversation, like to visualize it. Okay, so the very first one is always the trigger, which is we're gonna drag this when the green button is clicked. We're gonna drag that one first, because there's always a trigger to add to an event, for example. Okay, in the next program also, I will share about the trigger, but yeah, we're talking about like if you want to start a thing, there always must be a trigger. So for example, if I want to make the Pico talk, I must press somewhere else first, or maybe I click on Pico, right? That is the trigger. So we can say that, okay, when the green button is clicked, then Pico will talk, for example, maybe like you mentioned, add a sound. So, okay, then we can get a sound. So from that, we can record from this sound. Either you want to record yourself, okay, for example. So it will allow me to use my microphone. Okay, then record a sound. Hello everyone, my name is Pico. Okay, so if you like that, then you can save that record, okay? And let's go back to our code. All right, so when this one is clicked and we're gonna go to sound, what do you guys think will be next block? It's gonna play sound until done? All right. So we can do start sound. Which one is the sound? So funny. So recording one, the one that I record my voice just now. Okay. And then we also can give them a conversation. So we can say hello for how many seconds, for example. So once we run the trigger, we can see, okay, let me clear this. Okay, look for Pico over here. Once I click green sound, hello everyone, my name is Pico. So we can put like that. Even if you want to add more, hello everyone, a full text, for example, you can also do it as a subtitle. So you guess for how many minutes it will, how many seconds it will appear. So, okay. So yeah, that one. Okay, just a simple one for that. Okay, Anyone want to add more tasks to this? We have add sound, conversation. Probably you want to move it here and there. What do you guys think? Anyone want to add more tasks to this sprite?
Can we make it walk to the other side?
Yes, we can make it walk to the other side. So for example, this Pico actually has few costumes, right? So they have like this, and this. Oh, but it's more like expression. Okay, but yes, we can make it walk to the other side by adding a movement. So what do you guys think? When we want to add a movement, it will involve which part of the code block?
Motion?
Motion, good. So we're gonna point them, okay? Whenever we can ask, it depends if you want to ask the Pico move towards your mouse pointer, for example. Okay. Oops, this one is only turn. I'm gonna end it, but we're gonna move how many steps, for example. Okay. But also we can separate that event. So for example, when the green flag is clicked, okay, it will start sound recording, but it will always also move 10 steps until finish, which is, are we gonna divide them into a program? For example, we can add this, okay? So that will involve the if and then situation. Okay, so for example, if, okay, when the green flag click, Pico will start playing the recording. If the recording play, then Pico will walk. For example, will walk 10 steps to the other side. Okay. Right? So they're actually also like a glide, all right? Or maybe you want to set them to exact position, which is the position you can see here. Let me put it in red color pen. X and Y. So how do you want to know the X and Y? When you move the Pico, you will see actually the X and Y is actually changed, right? So you will move toward that X and Y. Instead of move, we can also ask them to move there, okay? So the X is 136. Negative 69, right? Okay, so for example, if you want to have exact animation like walking, you have to create the costume for walking costume. So actually that one also we have in the sprite. Okay, we're actually, there's a lot of like maybe specific dancing. So you can see when you put the cursor or the mouse to that sprite, it will show you the movement. So you can choose either this one, like this one, walking, right? So if I use this sprite, I can exactly use that animation to walk to the other side. Okay. typical, we have normal, but only emotion. Okay, so that one is for the simple programming, like that involving a block programming. Okay, now let's move to the second one, which is construct tree. Okay, so for this one, I'm just gonna impose also exercise. Here the drawing first. Oops. So this construct is actually it's quite eye-catchy for the kids because they come up with their own video game. And it's more suitable for the video game lovers. They actually did a lot of part of animation, more than just doing a conversation lah. It's involved more more event, a descriptive event. Okay, so for example, in this construct tree, okay, same, we have the output, okay, which is the front end and also the back end. So what you can see now is actually the front end, okay, how the game will looks like. This is the event sheet one, or event page we call. That is where you will code all the progress, or you will trigger the event. Okay, so for example, I always start them with the back end first. We want the student or the kids to understand, okay, the back end and how it works first. So how I'm gonna explain this to kids is actually, I also try to imply the real things example for them. So like mouse, this is the trigger so that the space shooter, okay, can spawn a bullet or maybe shoot a bullet. So how do we want to relate with our real life example? It's a trigger, it's an event and action, okay? When there is an event, always there is an action. A simple event and action that we can give them is, for example, when you go to kitchen, okay, what you're gonna do? So the logic way is when they go to kitchen, it's always related to kitchen. For example, maybe they will help their mom cook. Maybe they're gonna open the fridge. Maybe they're gonna cut something or eat something, right? So there is the example that can relate. They're not gonna give the answer that, oh, when I go to kitchen, I will take a bath. No, they never answer like that. They will usually say something that related to kitchen, right? So they actually also kind of applying this to the game. So when you want to trigger that action, you must have the case first. So for example, like this one, mouse, very specific. So when you click the mouse, on which button you click? So it will be most of us doing of the left button click lah, right? Okay, and also what happened once you click the button or the mouse? Okay, so the space shooter will do exact action. So that's actually when they understand this, a lot of them already understand the event and action, how to do it. It's gonna be easy for them to come out with their own, front end, because they already know how to do it at the back end. All right, so let's try to do this. Okay, I'm gonna share with you guys first the what they call the output of this game. Okay, I'm gonna share with you guys another screen for the output. Okay, so this is how it looks like. Okay, wait. It's just a blank screen. Okay, there you go. So there you go. I can move up and down I can shoot the aliens, enemy. Okay. All right. There you go. I can come back. So this is the output. Now, we're gonna give them a task. What happened once you shoot the enemy? It's not gonna end there, okay? It's not gonna, okay, I shoot the enemy, okay, game over. No, most of them will extend the situation. Oh, teacher, we can do explosion, for example. Okay, then I will trigger them to ask, how do you do the, how did you do the explosion, for example? So then they will create the sprite, and also here's a few things I'm gonna share with you guys how to create a new items or object. Usually we're gonna insert new object, and there is a few types of object you want to create. Either you want to create sprite, you want to create text, or even you want to input the mouse, the trigger. So the trigger here is always related to the software function. Like, are you gonna use gamepad? Are you gonna use touchpad, or the keyboard itself, or maybe mouse? Okay, so that's it under the general part. We're gonna create our own explosion, for example. Okay, yeah, this is the part where actually you can be creative. I usually encourage my students to come up with their own kind of arts. So usually we go to another site or another website to create, to draw apps, something like that, and pixel art, and they kind of come out. Some of them we find it very creative on their own. So yeah, so for example, we're creating an explosion. Okay, and I'm gonna just refill that color. Okay, me myself is not really that creative, but yeah, I'll try for today. Okay. Okay, so yeah, that's my explosion. All right, so yeah, as you can see, I created the explosion over here. I can resize that. There's a few enemies. That's the enemy, that's the player. So our aim is, again, we will highlight to the student, our aim is to make explosion. Once the player shoot the enemy, it will have explosion will happen. So that one, we have to code it in the event part. So this is a kind of, also I mentioned, like storytelling, okay? The first event, once you click, player will shoot. Second one, the bullet will go on collide with the enemy. And then when two things collide happen, okay, both destroy. And then you can add more. So once the enemy destroy, what will happen? You can say, once the enemy destroy, okay, there is the action, enemy will spawn another object. What's the object? It's gonna be our explosion. For now, the layer part is only 0, so yeah. All right, so let's take a look of how is it. It's actually a step-by-step procedure. If something doesn't happen, then we have to figure out something why it doesn't happen. So for example, let's take a look of this example. Okay, when I click, it will shoot, it will explode, but the explosion is not destroy. It's just gonna boom like that. How do I want to make the explosion or the boom itself disappear? It's not gonna stick on the screen. So that will always involve another function or another part in the game, what we call as the effect, okay, or the behavior. That's where the part that we need to add the behavior, okay, to the explosion. So again, we relates to the real things example. Explosion, what is the behavior? Usually when you see accidents and then or maybe there is a factory explode, there is explosion, a big explosion, usually we will see smoke, and the smoke, the characteristic, it's gonna fade away. So they will okay think like that. So there's okay fade. So actually all of this behavior, actually they have the description under there. So when you add the behavior, then only you can see the logic is there. Okay, so I'm gonna share the last output for you guys. There you go. So we can see this is a step-by-step procedure, which actually they will try to dig around the information. Okay. So actually you can do extra more than this. That's why we actually develop the module into kind of extensive module. So all of them will come out with actually a different kind of output. We set them to have this. Okay, we set them to have this objective, and then they always can come out with a different. Some of the kids wanted to do it this way, like a horizontal way. Some of them, when we say, okay, create a space shooter game, they will think about another different kind of space shooter. But we didn't stop them. We encourage them to come up with their own way. All right. So that is some of the part that I can share, or some of the program that I can share for today. So I think we already touched. Let me go through this slide first. We have more. Yeah. So I shared with you guys some of the software that we use and program. So I think you guys already have the idea of how this coding is not really that hard. It's always start with a simple one always. Okay, so yeah, I think that would be all. Yeah, that will be all for our session today. Other than any useful resources and support materials, I will provide you guys onwards, and then our team also will give you the information. All right. So,
Nina.
Yeah.
Yeah, can we have like a 5 to 10 minutes Q&A session for the
Oh,
floor
yeah.
to ask
I'm
some
about
questions?
to I'm about to sum up Q&A. All right. Okay, so before we go into the Q&A part, okay, I think I just want to share a bit, like for teachers out there, it's always a good chance that we have this awareness, as a teacher, we always want to give the best for our student. Even me myself, I'm not from the coding background, but I always find something new that we can contribute to our community itself. Like it doesn't have to be we perfect at that thing. Like it always can be the starter. For example, like me myself, I never think of end up here in a coding or maybe environment, but I found that it always start with my intention that okay, I want to educate our future generation. So the education part will not stop only there. It will not only stop like, okay, I don't feel like to teach anymore. So we always can come and contribute to the community in another way around. Either we can be a part-timers, or we can do the education itself by ourselves. So I think honestly from my side, I'm having fun in doing all this education, and I think I still want to discover more. I believe there is more more futures incoming lesson that I didn't encounter yet. Maybe I didn't encounter a behavior problem. I'm not sure how to say it, but in the classroom, there always be like um, what they call behavior problem. But how do you want to encounter this problem? By learning how to modify that behavior. So I think as educators, instead of having the patient, you also have to be very patient, patient in a way, very sabar, in encounter your student. But I hope all of our educators out there not gonna stop to teach our future generation. So yeah, I know being educators is not easy, especially nowadays. But I do really hope that all of us can contribute to our community. All right. So that is a few words from me. Is there any Q&A session for next? Then you all can share, can start. Okay, so if we have a Q&A question, then I'm ready. Nick?
Thanks very much for the session, Nina. So just to confirm again, we'll be getting the deck and maybe the recording after the session, is it? For people to refer back to?
Yes, I think Nick and our team will work on that for the recording and also the link update.
Yeah, the recording will be shared after we upload to YouTube. We'll share to all the participants after that. Yep.
If anyone is interested to come on Saturday, then what will they learn and how much more after that session can they become an instructor or facilitator also? In case anyone is interested.
Sorry,
That makes sense. Oh, because the Saturday
I can't hear you.
Hello, can you hear me now? I'll type my question.
Okay. Hello.
Ina, she will type the question. You can check the chat.
Oh, okay. All right. Oh, okay. For the Saturday session, will the participant who join immediately qualify to be trainers for coding session with train kids in future, or we need to attend a series of session? Okay, so well, basically, we do have like agreement. Okay, first agreement. So those who interested, like upcoming Saturday session, we already like provide them the learning materials ahead. So I don't think that's his problem. If you want to directly come and join with us, we will give direct you the instruction, like if you agree with all the agreement, I think there will be no problem, because all the learning materials is kind of self-study. So our session is always like weekly session. So I believe there is always a time for you to do the self-study. So yeah, there will be no problem for that. Okay. because each of our course or workshop, they will always have a short TTT. So once you already get to know how to run the software, then it's just gonna be easy for you to start off, because we have the learning materials and the teacher guides for you to uh, for you to. Any more questions? So if you're interested, then you can register to our link provided, Train the Trainer, for our coming 17 session.
Someone has a question on the chat. Will there be a certificate for this Saturday session? Hello, Nina. Hello, can you hear me? Hello.
Is there any question?
Nina, sorry. Jessica was asking the questions by Rain. Will there be a certificate for this Saturday session? Nina, hello? Jessica, I think Nina can't hear you. Yeah.
Oh yeah, sorry. I wonder if anyone else can clarify whether for rain, whether there'll be a certificate.
Yeah, let me get back to you as soon as possible on this because we're asking our team. All right?
Okay, sure. Thank you so much.
No worries.
Hello, can you hear me?
Yes, can hear you.
I'm interested to know for the coming Saturday, what are we going to learn? What are we expected to learn?
Nina, can you hear the questions?
I think I'll just type it in.
Hello, can you hear me?
Yes.
Yep. Okay, so you expect to learn on the tutorial on a Scratch lesson, on a brief Scratch lesson. Well, we're gonna give you the self-study first, the learning material. So from chapter lesson, so basically for every lesson that we have the framework. So we need to inform you the framework first, how we run the course itself for our from iTrain Kids, and then we're gonna do a little bit TTT or training to the trainer itself for level 1. So after that, when you become familiar with Scratch, then you can proceed to level 2, level 3. But level 2, level 3, if you're already okay with the learning materials, then we do not provide the TTT lah. But anyway, we always give the learning material first for you to go through, right? Once that, then we're gonna give you the step by step of the weeks, because in every course we will run for 12 weeks. For our framework, it's 1.5 hours weekly. Okay, so basically in every week you already know what to teach already for your student. There is already like an exercise and also a lesson and tutorial will involve in the 1.5 hours of weekly class. Okay. We can give from our team, update from our team that we can give the certificate of attendance. Okay, we will give certificate of attendance. And to clarify someone that actually each of our course have 3 levels. So the one that you will sit on this Saturday is Scratch level 1. Okay, so from that, you always can go further for level 2 and level 3. Okay, either it's Scratch or other programs. For example, maybe Construct 3. Maybe you think that you want to teach Construct 3 because it's more interesting for you. So yeah, each of our course, we have 3 levels. All of them, we have the self-study material and also the teacher guide for you to conduct. So like every week, you know what to teach already. You already go through weekly, right? And also what platform you use for sharing your materials. Well, basically at the moment we are, for keeping all of the files, we still develop the Google Drive. We still refer to Google Drive, but in the future also, we actually still looking for the other way, which is Google Classroom. Other than that, our website, like some of our file from the website itself, it's already saved with the website program itself. So the student will just upload from that website. Okay. How long does it take to master Scratch? Well, I think it depends on the learners itself. If you read frequently, then you will master very fast. I can tell you that. Because it depends on your understanding in coding itself, like how fast you can catch up. But I think mostly so far, the Scratch itself is very simple because it's very direct in a way. You just treat it how like a storytelling, step-by-step procedure. After A, there must be, and then if there is not B, there is another option of C. So yeah, it's actually, for me myself, I learned Scratch and then all this coding. Definitely take time lah, but if you, like I said, if you read frequently, exercise it frequently, then it's gonna be easy for you. Yeah, so everyone can take about our iTrinkits website. We have the different module also. So different module is a different outcome. Okay. Is there any other questions? All right, I guess if there is no other question for that, then thank you for your time. Okay, I appreciate all of you guys' time. Okay, I thank you for your time, able to join this session. I hope I can give benefit to you guys. All right, see you all next time. Bye-bye.